Section 2.5, Linear Inequalities. A linear inequality is the result whenever the equal sign in a linear equation is replaced by any one of the symbols less than or equal to, greater than, or greater than or equal to. So for example, the statement 2 by the quantity x plus 3 plus 1 is greater than 0 is a linear inequality. If this were an equal sign, we'd have a linear equation. But since we've replaced the equal sign with a greater than, it is a linear inequality. Similarly, 3x plus 5 is less than or equal to x minus 8 is a linear inequality. We've replaced an equal sign with a less than or equal to sign. Inequalities in the number line. We often use a number line to help us display the solutions of a linear inequality. So for example, if we had x is greater than 3, what we would do is, let's first show where 0 is. So let's say here's 0, and here's 3. For x to be greater than 3, the numbers that are greater than 3 are to the right of 3. So we would shade the number line to the right and the arrow. And since it's a strict inequality, it's greater than, not greater than or equal to, what we will do is put a parenthesis opening in that same direction. X is less than or equal to negative 2. Alright, so again, here's 0. Here's negative 2. Less than negative 2. The numbers that are to the left of negative 2 are less than negative 2, so I would shade to the left of negative 2. And since it's an inclusive inequality, we will use a bracket at the negative 2. So, if we have a greater than or a less than, we use a parenthesis. If we have a greater than or equal to or a less than or equal to, we will use a bracket. And these open in the direction of shading. Why don't you try these on your own, the remaining two examples on this page. X is greater than or equal to 4. So here's 0, there's 4. Greater than 4 would be to the right. And since it's an or equal to, I will use a bracket in the direction of shading. X is less than negative 1. There's negative 1. Less than negative 1 would be to the left of negative 1. And since it's less than, I will use a parenthesis in the direction of shading. As with an equation, we can check to see if a given value is a solution to an inequality by simple substitution. For example, if we're given the inequality negative 3x is less than or equal to negative 8, and we're asked to check if x equals negative 2 is a solution. Negative 3 times negative 2, is this less than or equal to negative 8? Is 6 less than or equal to negative 8? False. Negative 2 is not a solution. Let's check 3. Negative 3 by 3, is that less than or equal to negative 8? Negative 9, is that less than or equal to negative 8? True. X equals 3 is a solution. Why don't you try the other one on your own? 3y plus 5 is greater than or equal to negative 8. Check for y equals negative 3 and y equals negative 5. Three by negative 3 plus 5, negative 9 plus 5, negative 4. Is negative 4 greater than or equal to negative 8? Yes, it is. So therefore, y equals negative 3 is a solution. Y equals negative 5. 3 times negative 5 plus 5. Negative 15 plus 5. Negative 10 is negative 10 greater than or equal to negative 8? False. Y equals negative 5 is not a solution. As with linear equations, we can sometimes use tables of values to solve a linear inequality. Here we are asked to use a table to solve the inequality 5x minus 2 is greater than 3. So what we can do is set up some values for x and substituting. Let's see, 5 times negative 2 minus 2 is negative 10 minus 2 is negative 12. Is negative 7. And you can do the we can fill out the rest of this table. We would have negative 2, 3, and 8. Now, we know where it's equal to 3. So previously we said, well, 5x minus 2 equals 3 when x equals 1. So what we'll do now is we'll think of this as our boundary. And instead now we have to decide, well, wait a second, we don't want equal to, we want greater than. We want the outputs to be greater than 3. Is negative 12 greater than 3? It is not. Is negative 7 greater? Is negative 2 greater? 8 is greater than 3. And it is to the right of the boundary. And in fact, if we were to make another part to the table, if x was 3, this would be 13 and this would be 18. And these are also greater. So the solutions are to the right of 1. And so what we would write is the solution is x is greater than 1. Now if the inequality was more complicated, let's say we had 2 times the quantity 3 minus x is greater than or equal to negative 3 times the quantity x minus 2, we would have to have a more thorough table of values. So what we would do is, again, substitute and evaluate. So we'd have 2 by 3 minus negative 2. That's 2 by 5, which is 10. And continuing with the row for 2 times 3 minus x, we would have 8, 6, 4, and 2. Then for negative 3 by x minus 2, let me go with the negative 2 again. So we'd have negative 3 by negative 2 minus 2. So that would be negative 3 by negative 4, which is 12. And continuing with that row, we would have 9, 6, 3, and 0. So again, if it were an equation, the solution would be x equals 0, because that's where the two are equal. 2 times 3 minus x is equal to negative 3 times x minus 2. They are equal here when x is 0. But that's not what we want. We want the 2 times 3 minus x row to be greater than the negative 3 times x minus 2 row. Is 10 greater than 12? No. Is 8 greater than 9? No. Is 4 greater than 3? Yes. Is 2 greater than 0? Yes. And if we were to continue this to the right, we would see that the top row is greater than the bottom row to the right. And so the solutions are, again, to the right of 0. So therefore, x is greater than or equal to 0 would be the solution. Now, tables can be useful to solve inequalities, but sometimes we like to have a more procedural way of solving inequalities. Fortunately, we can use the same basic ideas we used for solving equations. We just have to be a little bit careful about a certain issue. We have an addition property of inequality. We are allowed to add or subtract numbers from both sides of an inequality, and it wouldn't change the symbol of inequality. So if we have a is less than b, we can add the same number to both sides, and a plus c is less than b plus c. However, for multiplication, we have to be careful. If we are multiplying or dividing by a positive number, if c is greater than 0, then we are allowed to multiply both sides by the positive number, and it doesn't change the symbol of inequality. If a is less than b, then a times c is less than b times c. However, if c is less than 0, if we're multiplying by a negative number, we have to flip the symbol of inequality. All right, so notice, if c is less than 0, then the inequalities a is less than b and a times c is greater than b times c are equivalent. So, what we need to remember here is each side of an inequality may be multiplied or divided by a negative number, provided the inequality symbol is reversed. If you multiply both sides of an inequality by a negative number, you must flip the symbol of inequality. Same holds for division. If you divide both sides of an inequality by a negative number, you must flip the symbol of inequality. So for example, if we had x plus 4 is less than 1, we are allowed to subtract 4 from both sides of the inequality. And x is less than negative 3. If we have 4x is greater than negative 20, we are allowed to divide both sides by 4. And x is greater than or equal to negative 5. Now, here we're asked to solve. We have negative 5x plus 4 is less than 44. Alright, so as if we were solving an equation, the first thing I would do is subtract 4 from both sides. Now, I would divide both sides by negative 5 to isolate the x. But now I must remember, since I'm dividing by a negative number, I must flip the symbol of inequality. It was a less than, now it is a greater than. X is greater than negative 8. Why don't you try the other one on this slide on your own? Alright, 69 is greater than or equal to 3 minus 11x. First thing I would do is subtract 3 from both sides of the inequality. So 66 is greater than or equal to negative 11x. I would divide by negative 11 to isolate the variable. Since I am dividing by a negative number, I must flip the symbol of inequality. 66 divided by negative 11 is negative 6, and we have the x isolated. So now I like to write the x first, so if negative 6 is less than or equal to x, I can take the whole thing and flip it around, and I can write x is greater than or equal to negative 6. Five by the quantity x plus 2 is greater than negative 2 by the quantity x minus 3. Like before, I'm allowed to use distributive properties. So I'd have 5x plus 10 is greater than negative 2x plus 6. I like to bring the variables to the left, so I would add 2x to both sides. And while I'm at it, let's see, that would give me a 7x on the left. And I'll go ahead and subtract 10 from both sides. So I have 7x is greater than negative 4. And I'll divide by 7. Now, should I flip the symbol of inequality? Well, I divided by 7, which is a positive number. I do not need to flip the symbol. X is greater than negative 4/7. Why don't you try the other one on this slide on your own? Alright, applying the distributive property, I would have 4x is greater than or equal to negative 21 plus 6x plus 1. Combining like terms, negative 21 plus 1 is negative 20. Alright, I see I have variable terms on both sides, but only one constant term. So I'll subtract the 6x from both sides, yielding negative 2x is greater than or equal to negative 20. I'll divide by negative 2 to isolate the x. And since I divided by negative 2, I must flip the symbol of inequality. And so therefore x is less than or equal to 10. So as before, if we have decimal or fractional coefficients, we can use some certain techniques to help simplify the process a little bit. I have the inequality 0.8x minus 0.5 is less than x plus 1 minus 0.5x. I can multiply both sides of the equation by 10. And since I'm multiplying by a positive number, I do not need to flip the symbol of inequality. This would yield 8x minus 5 is less than 10x plus 10 minus 5x. Combining like terms on the right-hand side, I'd have 8x minus 5 is less than 5x plus 10. I like to move the variables to the left, so I'll subtract 5x, yielding 3x on the left. And I'll go ahead and add 5 to both sides to bring the non-variable terms to the right. So I now have 3x is less than 15. Dividing by 3, no need to flip the symbol. X is less than 5. Five x over 8 minus 3x over 4 is less than 8. I would multiply both sides of the inequality by the LCD. The LCD for 8 and 4 is 8. So I'll multiply by 8. So I'd have 8 over 1 times 5x over 8. Minus 8 over 1 by 3x over 4 is less than 64. All right, the 8's reduce here. So for the first term, I have a 5x. The 8 over 4 would reduce the 4 out, leaving a factor of 2. 2 times 3x is 6x. It's still less than 64. 5x minus 6x is negative x, is less than 64. All right, so now to isolate the variable, I would divide by negative 1. Since I'm dividing by a negative number, I must flip the symbol of inequality, and x is greater than negative 64. And we'll finish with a couple of applications. The first application. A student scores 65 and 82 on 2 different 100-point tests. If the maximum score on the next 2 tests is also 100 points, what score does the student need to maintain at least an average of 70? All right, so let's see. The average for the 3 tests would be 65 plus 82 plus the unknown divided by 3. And we need this average to be at least. Now, at least means it can be that number or better. So, at least, so greater than or equal to a 70. So there's our inequality. First thing I would do here is multiply both sides by 3. So that would give me 65 plus 82 plus x must be greater than or equal to 210. 65 plus 82 is 147. So 147 plus x is greater than or equal to 210. And let me subtract the 147 from both sides. And so x is greater than or equal to, let me do some subtraction here. X is greater than or equal to 63. So the score needs to be at least a 63. All right, and one more application. One car rental agency charges $20 per day plus $0.25 per mile. A different agency charges $37 per day with unlimited mileage. For what mileages is the second rental agency a better deal? Now, if it's a better deal, it's going to cost less. All right, so for what mileages? So let's say that x is the number of miles. Then the cost at the first agency, well, we'd have a set $20 per day plus 0.25 times the number of miles. The second agency charges a standard $37 per day. All right. But wait a second, we don't want them to be equal. We want the 37 to be less than the other one. Well, that's the same as saying the first one is greater than. So we want the 20 plus 0.25x to be greater than 37. All right, so now let's solve the inequality, subtracting 20 from both sides. So 0.25x is greater than 17. And let's see, dividing both sides by 0.25. That wouldn't change the symbol. Oh boy, 0.17 divided by 2.5. I guess we got to do a little bit of side work here. 0.25 into 17. Well, let's bring our decimal over 2 places. 25 doesn't divide into 17. 25 will divide into 176 times. That'd be 150. And 25 will divide into 208 times evenly. So x is greater than 68. For what mileages is the second rental agency a better deal? Second agency is better. For mileages greater than 68 miles.